Purpose of this video is to give you some ideas about performing a statistical analysis on your data. I'd probably recommend before you do that is that you highlight your results, highlight these results data in Excel and give it a bit more detail. So using these little zero numbers, should be able to give it all 3 decimal places. Okay, so I'll go over here. Basically in our statistical analysis, we're always trying to answer that question, do females have a slower reaction time than males? So always keep that in mind when you're comparing all these numbers. First thing we're basically looking at is the measures of central tendency, which are our averages. So you should really never write average in your report. You should always be referring to either the mean, the median, or the mode. If you just write average, no one knows which one you're referring to, which is important because they're different measures of central tendency. So the mean, or the mathematical average, is calculated using all the values. You guys know, add them all together, divide by how many scores there are. Okay, and it's affected by outliers. So you can experiment with your own data, pretend that someone took 5 minutes to do the test, so type in 600 or some big number, and see how the mean changes. Okay, on the other hand, the median wouldn't change very much at all. Okay, the median's the middle score, and we know that 50% of the data, so half of the people, take longer or shorter than this value. Okay, it's a spot in the middle. So we'll be using these a lot to compare our data sets. The mode is the most common score. Okay, probably not really that relevant for this data. It's just sometimes randomly 2 people will have the same reaction time, but that doesn't really tell us anything about the group as a whole. Okay, so you might want to write some comment about that in your question 3. Okay, and just state that we're really focusing on the mean and the median to compare the males and females. Now we're also going to look at the measures of spread, okay, including the range, which is the maximum minus the minimum, just looking at how spread out the data is. Okay, also look at the interquartile range. So your box and whisker plot divides the data into 4 quartiles. So Q1 is where 25% of the data is. So Q2 is where 50% of the data is below or above. And Q3 is where 75% of the data is below or above. Okay, and we've got the maximum up the top. So looking at one of these box and whisker plots, make sure we can see the axes. Okay, so I'll use the female one just so we can actually read off something. So the fastest time was about 0.2 seconds. Okay, the top 25% took about 0.3 seconds. The top 50%, that was finished at about 0.4 of a second. Okay, the bottom 25% started around 0.55, okay, and my slowest time was 1 second. So that's going to be important when we start looking at how much variation there is in the data and see how many extremely fast or slow people there are. We can look at that in more detail later on. And we've also got the standard deviation, which is just another number of how spread out the data is. Okay, a big number means it's really spread out. Small number means it's not that spread out at all. There's not much variation in the data. Okay, we also can look at the extreme values as well. So if there's a maximum that's really big, if there's someone that's really slow, we might want to comment about that in our response. Okay, so I'm going to write all of this analysis just in dot points. Okay, and you can't really copy this because you need to obviously look at your own data and see what results you have. But hopefully this will help you out somewhat. Okay, so you write some introduction about how you're using these measures of central tendency, and then we'll just start looking straight at the male and female comparisons. Okay, so if I'm looking at the male and female mean and median, okay, they are pretty close. So median 0.39 versus 0.39, and the mean 0.45 versus 0.46. So I'm going to write something in here that might make some little heading, or I'll have some introductory paragraph here. I'll just male versus female. Might state that the mean reaction time doesn't vary much between the two genders. Okay, and when we're doing this analysis, we want to quote the actual values as well, not just make broad comments. So I'll write male of 0.452 versus female of 0.463. I'll also write something about the medians. Okay, median reaction time also has no significant differences. Okay, and I'll state what these two are as well. Obviously you'll write this out a lot neater than me. Put linking sentences and all those sorts of things. You might be wondering how you're going to fill in 700 words. I've already written 105 words and I haven't really even done anything. Okay, mean and median about the same. I'll discuss here about the mode, even though I'm not going to use it. Okay, the mode for females is a lot slower, and I better refer male of 0.37 versus female of 0.4, but won't rely on this statistic. If I look at the minimum and the maximum, so the slowest female is a lot slower than the slowest male. However, also the fastest female is a lot faster than the fastest male. I should also look at the measures of spread. Okay, so females have a larger range. Okay, so you can calculate the range for both of these. The male range is 0.94 minus 0.32. And find out what that value is. Female is 1 minus 0.2. So I'm just grabbing those from the minimum and the maximum calculations. I'll look at the interquartile range. The female interquartile range is almost double. And male of 0.1 versus female of 0.21. So it's more than double. And I can also look at the standard deviation as well. Female standard deviation is also significantly larger. Okay, so basically compared all of those statistics, but we need to say, well, what does that tell us in terms of females or males having faster reaction times? So we didn't find much difference between the measures of central tendency. The difference between measures of central tendency. Yeah, the mean and the median are basically the same. The mode we don't really care about. Okay, however, there was much more variation in the data for the females. So what this is going to mean is that if we test a female, there's a bigger likelihood that she's one of these extremely slow or extremely fast drivers. Fast reaction timers. Okay, so this may indicate that the reason Michael made the claim was because of the existence of some really fast or slow females. In this case, the existence of some really slow reacting females. And that might be what he's basing his comment on. And so you can say, well, more valid would be to recognise that there's this variation, but on average, so using a mean or median comparison, there's actually not that much difference. Okay, so then we'll look at, well, there's not that much difference, but what if we focus just on the overweight males and the overweight females? See if just looking at that little subclass, that little group of people makes any difference. Okay, so I'll put the male overweight versus female overweight. And again, I'll just list some dot points, nothing too serious. Okay, so we can see that the means are essentially equal. Mean reaction time is essentially equal between the two. Yeah, they're both 0.5, and you would reference this. Yeah, I just don't want you to sit there watching me type forever. But if we look at the median reaction time of males is slower than that of females. There we're comparing 0.505 and 0.45. Okay, so the median is essentially the same. Sorry, the mean is essentially the same, but there's lots of variation in the median. Okay, again, the mode we can have a look at, but it's pretty much irrelevant. And even when we look at the mode, the overweight males don't even have a mode, so it's not even worth comparing. Yeah, they have no mode because everyone got different values. That's the idea. Okay, what other comparisons can we make? We'll look at the spread again. So looking at these key spread statistics like interquartile range and standard deviation, the female spread is significantly different. So female interquartile range and standard deviation is much larger. Okay, and that will indicate potentially some really slow reactors and some really fast reactors. Okay, compared to just the bulk male versus female analysis that we did. Okay, and we can make similar comments as we did for the male versus female. Okay, and also we can look at some of these quartiles in particular. So if if we look at these overweight females, that Q3 point is pretty much where the slowest male is. So we'll be able to make some comments about these quartiles. So I know in this case that all of the overweight males, because of the whole box and whisker plot, are faster than the slowest 25% of overweight females. Okay, what that means is that we've got a significant percentage of females there who are really slow at reacting, because they're all slower than, so that 25% of females, they're slower than all of the males. So that might be something significant that we're going to note. If we look at the minimums, they're exactly the same. Okay, so the fastest male and fastest female are essentially the same, have essentially the same reaction time. There's 0.3. Okay, so I've pretty much done my analysis, and then I'll write some statement about what happens when we look at the overweight variable. Okay, in this case, in the case of overweight individuals, I'm going to say that the average, or the typical female is a lot faster than the male. Okay, full stop. Okay, but I also need to make note that we've got that large spread. Okay, however, there is a lot more variation in the reaction times of overweight females, and therefore exist some extremely slow females. Okay, and then I'll also make comment about how that comparison of all the males and the 25% is supported by that. So supporting this concern is the observation that all of the males react faster than the slowest 25% of females. Hopefully in all of your sets of data you can find some similar sort of comparison. So you'll need to sort of look creatively around at your graph, see where those 25, 50 and 75% levels are. Hopefully you can make some comment there that'll either support or reject that statement that Michael made. Okay, so a lot of this is not clear cut. We're not just looking at the mean and saying females are faster. We need to also look at the spread of data to see whether it's a strong or a weak conclusion. Okay, so in conclusion, even though the median female reaction time is significantly less than that of the males, there are some females who are significantly slower than the males tested. Okay, which may have been the basis of Michael's claim. Okay, eventually we'll have to make a decision, but we're going to do it on a rational basis after considering all of these different variables, not just make the statement straight away comparing two means or two medians. In terms of the video gamers, just do a quick analysis on these guys. Okay, I'm already up to 400 words, and I'm just writing in dot points. So you should easily be able to spread these out. Don't just sit there with a blank page, just start making some comparisons. Say in terms of the video gamers. So even looking at here, I've got a similar sort of story. The mean and median seems to be about the same, but the spread is significantly different. So median score is pretty much identical. If I look at the means, the female mean is slightly slower than the male mean. Okay, so we've got 0.506 versus the female one of 0.534. Okay, so that's sort of going against what we've found in the other two sections, but that's okay. That's what our data revealed, so we'll have to deal with that. Again, okay, looking at the IQR and standard deviation is significantly higher for females, indicating some extremely slow and some extremely fast drivers, fast reactors are female, and I think that's about all. If we look at the bottom of the female box plot, those fastest 25% are faster than all of the males. Okay, so the fastest 25% of females are faster than all of the males. Okay, again, a few different things telling us a different story. Okay, so I might write some conclusion like, even though the typical female reaction time, so you can use typical instead of average. Okay, even though it's slower than that of the males, there are some extremely slow and extremely fast female reactors. I should probably also write in here another comparison that all of the males are faster than they're faster than the slowest 25% of the females. Okay, similar to in the male overweight versus female overweight. So these are all just things that you can mention, and then it's your job to really synthesize all this. In some instance, you'll need to just take a position and use data to support that. Okay, some extremely slow and extremely fast female reactors. Which may have been the basis of his claim. Okay, because we don't think that Michael actually did any statistical analysis of his own. Okay, so in conclusion, I'd say that the statement made was false. Okay, there is no real evidence to support the males having a faster reaction time than females. Okay, And we'll just use a sentence to summarize each of our findings. So overall, male and female typical reaction time was equal with variations present when we considered the overweight and video game playing variables. However, nothing significant to suggest that males are faster. Okay, always bring it back to that initial question. Is there evidence to support that? Michael may be able to comment more accurately on the situation if he refers to the variation. I shouldn't use variation all the time. There should probably be differences here. The variation in the data, like the measures of spread. Which indicate that there are some very slow female reactors on the road. Okay, so I've pretty much written almost 600 words already, and haven't even really answered the question in a proper format that you would write. Okay, so hopefully that's enough to, I guess, get you started on things that you can start to compare and see how you go. All right, good luck.